Hello everyone, this is Dr. G. Karthik Reddy working as Associate Professor in the Department of ECE, MLR Institute of Technology, Hyderabad. In this session, we are going to discuss on problem on characteristic function using Gaussian random variable. Okay, here we discuss the definition of characteristic function, significance of characteristic function, and the problems of characteristic function on Gaussian random variable. Okay, first of all, characteristic function. The characteristic function we are discussing for notation is phi x of omega, which is equal to expectation of e power j omega x. Okay, this is a general definition of characteristic function. Okay, why they are using this characteristic function means, okay, while you are solving the expectation, or while you are solving the mean square value, or while you are calculating for nth order movement about origin, okay, we require separate integral. Okay, for example, expectation of x we have to solve by using integral minus infinity x into fx of x dx. Okay, if you want to solve the mean square value, we have to take one more integral minus infinity x square fx of x dx. Okay, if I want to calculate for the next order movement, or up to nth order, if I want to calculate, we have to calculate for each and every integral. Okay, it becomes more time. Okay, more time, and it is also complex. Instead of solving in this procedure, you can solve by using one single integral, by using the concept of characteristic function. Okay, by using the characteristic function, okay, differentiation. Okay, if you are doing the first, okay, you expand this term, whatever the term you are expand this term. Okay, expectation we apply it. Then what you have to do means, you have to do the differentiation with respect to omega. Okay, then what you are having, d by d omega phi x of at omega equal to 0. Then whatever the coefficient you are going to get, that is expectation. Okay, coefficient will be, okay, it will become 0. Okay, it will be eliminated. Then you are going to get only expectation of x. Okay, this is the first order movement about the origin. Okay, then if you are doing the second order differentiation phi x of omega at omega equal to 0, then you are going to get expectation of x square. Okay, then similarly you can solve for the up to nth order differentiation, then you are going to get nth order movement about origin, that is expectation of x power n. Okay, all this you can solve by using one single integral or differentiation of that term. Okay, this is the significance of characteristic function. Okay, now next we are going to discuss the problems related to characteristic function. Okay, characteristic function is one of the parameter to understand the behavior of any particular random variable. Okay, you are having majorly you are having 6 different parameters. Majorly you are having the expectation. For example, if you are considering for a single random variable x of t, okay, a single random variable x, if you are considering expectation of x, mean square value, variance you are having, next skew you are having, next you can have the movement generating function, next you are having characteristic function. All these are the different parameters. Okay, all these parameters are useful for understanding the behavior of any particular random variable. Okay, this is the definition of the characteristic function. Okay, when you extend to the continuous random variable, this is the continuous random variable case, summation minus infinity to infinity. Okay, exponential to the power of j omega x fx of x dx. Okay, here where j represents the imaginary parameter, which is equal to square root of minus 1. Here omega lies between minus infinity to infinity. This is just a random variable. Okay, next you are having one more important property of the characteristic function is that the characteristic function and the density function form a Fourier transform pair, but with negative sign. Okay, both the relation you are having same thing. Okay, phi x of omega is equal to integral minus infinity to infinity fx of x. Okay, fx of x, here e power j omega x dx. Okay, generally you are having minus in the exponential term, exact Fourier transform. Here you are having the reverse sign. Okay, phi x of x is equal to 1 by 2 pi integral minus infinity to infinity phi x of omega e power minus j omega x d omega. Okay, these two are very important. Okay, while you are taking, whenever you are having only the density function, okay, they're given in the question that density function, they'll ask to calculate the characteristic function. Okay, if you get the characteristic function, you can calculate for nth order moments easily. Okay, this is one of the easiest approach to solve the nth order moments if you are having only the density function of that particular random variable. Okay, or if you are having only the characteristic function, I want the density function of that, then you can use this relation to calculate that. If you want to calculate the density function of any particular random variable. Random variable may be anything. We already discussed in the previous session. Random variable may be the binomial or Poisson or Gaussian or uniform or Rayleigh or exponential. These are the standard random variables which we are using in the real-time scenarios. Okay. Now here we are discussing with one of the example. Okay. These are the important properties of characteristic function. Characteristic function. Okay. This is we already discussed the distribution function. Okay. Whenever you are having, when you solve the by using this one, by using this relation. Okay. Your density function may be anything. Based on the density function, substitute the density function, simplify it, you will get the characteristic function of that particular random variable. Okay. Here we have a simplified form of the normal distribution or Gaussian distribution. Okay. Phi x of t e power I t u 1 minus 1 by 2. Okay. Of this. Next, this is a exponential distribution function. Phi x of t equal to lambda by lambda minus it. Or uniform distribution, that is phi x of t equal to sine of tb minus ta by t of b minus c. Okay. These are all the examples of continuous form. Okay. Continuous form of a random variable. You have the relation. This is a continuous form of the random variable. Similarly, you can use discrete summation I equal to 1 to n. Okay. E power j omega xi. Okay. P of xi. Here P of xi is a probability mass function. Probability mass function you can use for the discrete random variable. Generally, the discrete random variable which we are using is binomial and Poisson. Binomial and Poisson, both are the discrete random variable case. You can substitute in the probability mass function and you apply it, then you are going to get the characteristic function of that particular random variable. Okay, to understand that, we'll taking one example. Okay, I'm taking the characteristic function of a Gaussian random variable. Okay, Gaussian random variable. Here we are considering the normal. Normal means the notation is n. N represents the normal. X. Okay, x is a random variable. X is telling that we are having the mean and the variance. Mu represents the mean and sigma square represents the variance. Okay, mean, variance. Derive the characteristic function of that. Okay, derive the characteristic function of that. Okay, we'll solve this one. How to solve the Gaussian random variable? Okay, using this relation, we have to solve the Gaussian random variable. First, you have to solve the density function. Okay, if you know the density function of the Gaussian random variable. Okay, Gaussian random variable. Okay, it is denoted is like this: x fx of x. Okay, if we are considering this is symmetrical with respect to mean. Okay. Then you are having fx of x is equal to 1 by square root of 2 pi sigma x square exponential to the power of minus x minus mx or mu x whole square by 2 sigma x square. Okay. Okay. This is a mu x represents the mean and sigma x represents the standard deviation. Okay. This is the variance. Standard deviation means square root of variance is called standard deviation of them. Okay. Here, this is the notations. Okay, it is depending upon mean and variance of that. Okay, a normal or Gaussian random variable is depending upon mean and variance of that. Now we'll discuss the problem related to this. Okay, now we are having the characteristic function. It may be I or j. The definition: expectation of e power I tx. Okay, where capital X is a random variable. Okay, now substitute the. Okay, this is the PDF means probability density function of a Gaussian. Okay, probability density function of a Gaussian. Okay, this is the relation. Substitute that relation. Okay, substitute that relation in the density function. This is the formula of the continuous random variable of the characteristic function. you substitute that e power itx into fx of x. Okay, now whenever you are having the problem like this, then you have to go for a substitution method. Okay, this is one of the easiest way to solve any integration concepts. Okay, now to solve that, first you have to combine the exponential terms. E power itx e power minus x minus mu whole square by 2 sigma. You combine that. Okay, exponential powers will be, you are going to get summation of those terms. Okay, now x minus mu x a minus b whole square term, a square plus b square minus 2ab. Okay, you can use that. Okay, then you split this one, then what you are going to get, a square. Okay, you split and you divided by 2 sigma x square term plus itx. Okay, now next. Okay, now you can have the x terms common. Okay, this is my e power minus x square by 2 sigma x square plus mu by sigma square plus it of x minus mu square by 2 sigma x square. Now you take the complete square, formulate the terms in terms of x. Okay, now next you simplify it further. Okay, now next complete square, next you apply that, apply this term first. Now whatever you are having, expand this one, 1 minus 1 by 2 sigma square of x square minus 2x you take common, then you are going to get sigma square by mu by sigma square plus sigma square into it. Now next complete square, next you take the complete square of the term, then you are going to get the resultant of this, x square minus 2x of mu plus I sigma square t plus mu plus I sigma square t of whole square. Now the complete expression you simplify it further, then you are going to get minus, okay, minus x minus mu plus I sigma square t of whole square by 2 sigma square plus mu plus I sigma square t of whole square by 2 sigma square. Now you simplify it further, then what is that, you are going to get integration minus infinity infinity e power minus x minus mu by mu whole square by 2 sigma square into dx, normalize to 1. Then you are going to get the resultant e power minus sigma square t square by 2 plus I into mu t. This is a 1. Okay, the same thing you got in the expression of the normal distribution. Okay, if you know the formula of all the density functions, then it is easy to solve the problem related to the characteristic function, because we are having the relation, you can solve by using that relation also. Or if you don't know that, then you have to solve from the basic onwards, you have to solve the problem. Similarly, you can solve for the exponential distribution function, and similarly you can solve for uniform distribution function. Okay, all these problems are based on the based on the parameter of the density function only. Okay, density function, if there is an input, if you know the density function of all the random variables, then it is easy to solve the characteristic function of that particular random variable. Okay, this is the way you have to solve the problem related to characteristic function. Always stick on the definitions. Okay, definition is an important factor to solve the characteristic function. Characteristic function plays the role of one of the parameter to understand the behavior of that particular random variable. Here the random variable which we are discussing is Gaussian. Okay, likewise you can also solve for the remaining one also based on the, here all are the density function. Okay, for example, uniform, we are having the uniform is always defined only certain interval a to b, it is constant in this interval, which is equal to 1 by b minus c. Fx of x is equal to 1 by b minus c for the interval a less than or equal to x less than or equal to b, 0 otherwise. Now what you have to do, for example, uniform, okay, same, this is also continuous random variable, phi x of omega, you have to use the same approach. Whatever the approach you have solved here, same approach you can solve. Okay, here also integral minus infinity to infinity, okay, e power j omega x, okay, phi x of x dx. Here this is defined only for the interval a to b, change the limits, a to b, e power j omega x, here 1 by b minus a dx. Okay, you can take 1 by b minus a outside the interval, 1 by b minus a integral a to b. Okay, you solve this one. You substitute e power j omega x by omega. Okay, here in place of omega you are having t. Okay, then what you are having, a to b you have to substitute 1 by, then what you are going to get, you solve here 1 by omega into b minus a, here e power j omega. Okay, then what you substitute, that j omega b minus omega a. Okay, now multiply and divide by 2, then e power j omega theta minus e power minus j omega theta by 2 is represents e power j omega e power minus j omega theta by 2. It is going to represents what? Sine omega t. Okay, sine omega t. Okay, you can solve this one. Based on that, you get sine of tb minus ta by t by into b minus. In place of t, here we are having omega. Okay, the formula will be same. Okay, this is the way to solve the uniform. Similarly, exponential also we have already solved in the previous section. We shall discuss the density function. Okay, fx of x equal to lambda into e power minus lambda x, or lambda greater than or equal to z. This is a mathematical notation, graphical notation. This is a graphical notation, x fx of x. Then you have to substitute in the relation phi x of omega integral minus infinity e power j omega x fx of x dx. In place of fx of x, you substitute that one. Then you are going to get this relation lambda by lambda minus it, or in this case I omega. Okay, you will get lambda by lambda minus j omega. This is the formula you are going to get for exponential distribution function. Okay, this is a way to solve the problems while they are giving the problems related to the characteristic function, when they are giving the input as density function. When they are giving the input as density function, you have to use these formulas. Okay, whenever they are giving the formulas, whenever they are giving the one more type of problem, whenever you are giving the two different random variables and they are telling that both are independent to each other, then you can check the relation phi x1 plus x2 of t equal to phi x1 of t into phi x2 of t. Based on this relation, you can base, if the relation is satisfying, then the given or independent random variables, the characteristic function is also satisfying. Okay, this is one of the different type of model which you are going, which we can solve the whether they ask based on the question. Okay, we can first you have to understand the question. What is the random variable they have given? If you know the random variable density function, then it is easy to solve the characteristic function of that particular random variable. Okay, in this session we have discussed these concepts related to the how to solve the problem related to the characteristic function of any random variable. Thank you.